Welcome! In the last lecture, we successfully set up this physics climb function. One important thing here to mention is this function here, same as tick, will be run every frame. So once we are inside of the climb state, this physics climb here will be constantly run. We can use this function input delta time to help us to achieve many different things we need. So in this lecture, we'll look at how we can process all the climbable surfaces info. And let's try to narrow it down in here. What exactly do we need to process? Well, there are two pieces of information that we need. So first, we'll need the current climbable surface location. And the second one, we'll need the current climbable surface normal. These two vectors here are essential for us to do the calculation we need. So we'll first look at this climbable surface location. And for the math that we need to do later, it's mainly about vector subtraction. And just to provide you with a simple example, so you can see in here, I have two 2D points. And the first one, let's say it has a value of 5 in the x and a value of 3 in the y. I'm going to call it v1. And the second one, let's say it has a value of 3 in the x and 1 for the y. I'm going to call it v2. So here we are using two simple vectors to represent their locations. And now if I use v1 to subtract v2, what's the result that I'm going to get? So that's using 5 to subtract 3 and using 3 to subtract 1. And the result would be 2 for the x and 2 for the y. And this is the new vector that we're going to get. And if I move this vector to here and use these three vectors to form a triangle, this is my final result. And that's the math we need. So by using one vector to subtract the other, we can get a vector pointing from the second one to the first one. So now this position here, this is our character, and this position here, this is our climbable surface location. By doing a simple subtraction here, we can get a vector pointing from character to the climbable surface, and we can perform all sorts of calculation we need in here. And just to examine what we've just learned, I have a challenge for you. So here I have the same vectors, and this time I'm going to use v2 to subtract v1. What is the new vector that I'm going to get? Pause the video now and see if you can solve this by yourself. Welcome back. So, by using the v2 to subtract v1, we'll be using 3 to subtract 5, we'll get -2, and use 1 to subtract 3, we'll get another -2. So, this is our result, and this is our new vector. And if I move this vector to this spot and use these three vectors to form another triangle, this is the result that I'm going to get. You can see comparing to the last vector, the distance between these 2 points are still the same. But the vector here is the exact opposite. So we are getting a vector pointing from v1 to v2. And that's another important math calculation that we'll do later. So if we want to inverse the direction of a vector, we can simply multiply it with a -1. Keep that in mind. Alright, now that you know what we need to do with this climbable surface location, let's look at what we can do with this climbable surface normal. And first, we'll need to understand what is a surface normal. So when dealing with surface normals, we're mostly going to be dealing with face normal and vertex normal. So normals, they are unit vectors. They only have a length of 1. The valuable information it can provide is the direction information. You can see for the face normal here, it's simply just a line pointing straight out from the face, and it can tell us which direction this face is facing. And same thing goes for the vertex normal in here. It can tell us which direction this vertex is facing. And that's exactly what we need to do our calculation. Alright, that's the theory part. Let's start coding. Go back to my Visual Studio. I'm going to go to the header file, and inside of this climb core variables, I'm going to create two new variables. So the first one is going to be an f vector. I'm going to call it current climbable surface location. And the second vector, I'm going to call it current climbable surface normal. And if you recall, we are using a capsule trace to capture all of those different surfaces in front of us. So very likely that we'll have multiple hit locations and multiple surface normals. And we'll need to find a way to combine them as a whole. So I'm going to expand this climb core. And under this physics climb, I'm going to create another function. So I'm going to call this function process climbable surface info. And I'm going to create a function definition. I'm going to place this function under this physics climb. So place it in here. And first thing, I'm going to call this function. So scroll up inside of physics climb. So first, I'm going to call the function trace climbable surfaces. Since this physics climb will be run every frame, once we are inside of the climb state, we'll be using this function here to constantly fill in the useful information we need. And in case you forget, inside of this function, we're doing the capsule trace and we are assigning the hit results to this array. Alright, I'm going to scroll up, and below this function, I'm going to call the function that we just created. So it'll be this process climbable surface info. So place it in here. Alright, let's look at how we shall implement this function. So the first thing that I want to do, we're going to use the member variable current climbable surface location, and I'm going to set it to a 0 vector. And I'm going to be doing the same thing to the current climbable surface normal. And copy this, paste it in here. And the next thing that I'm going to check, so if this climbable surfaces traced results, so if this array is empty, then I'm going to return out of this function. Since this function here will also be run every frame, it's important that we zero out these two member variables at the beginning. Alright, once we get past this if check, I'm going to loop through this array. So it's going to be a range-based for loop. It's going to be const f hit result reference. I'm going to call this traced hit result, and I'm going to loop through this array. And as for handling multiple surface normals and multiple impact points, this is what I like to do. So first, I'm going to add all of these different locations together. So it's going to be plus equal the traced result, the impact point, and I'm going to add all of these normals together. So it's going to be plus equal traced hit result, the impact normal. And once we've extracted all of this information, at the end of this function, I'm going to divide this current climbable surface location by the number of elements inside of this array. So I'm going to use the function num in here. So by doing this, we'll be getting an average location from all of these possible locations inside of this array. And for the normal here, we can simply normalize it. So I'm going to copy this variable name. So this one is going to equal to get safe normal. And that's pretty much it. And one last thing that I want to do. So I'm going to scroll down to this trace climbable surfaces. I'm going to delete this true. So I only want to draw the debug shape for one frame, since we're calling this function every frame once we start climbing. And I'm going to delete these two truths, so I don't need to see the debug lines for this trace from iHeight. And I'm going to press Ctrl+B to compile. Alright, I have a successful compile. And to prove this is working, I'm going to print these two values out. So I'm going to use debugged print. And the message here, so this will be the climbable surface location. And I'm going to append another string in here. So convert this to a string. And for the color, I'm going to fill in fColor cyan. And for this in key, I'm going to give it a value of 1. Then I'm going to copy this function, and I'm going to paste it in here. So this one, this is the surface normal. And I'm going to copy this normal and paste it in here. And this time, I'm going to change its color from cyan to red and change its in key to 2. Alright, I'm going to press Ctrl+F5 to launch my editor back. Go back to my editor, I'm going to press play in here. Then I'm going to go to a climbable surface and press F. And you can see there's my surface location and surface normal. And we're doing this capsule trace every frame. That's great. And I'm sure you can notice that we can move our character again, but in a very weird way. And that's because we have our physics function ready. We should have our movement back. And we'll still need to handle to snap our movement to the climbable surface. And we'll do that later, but for now, our processing is working as expected. So this is the function for processing that I just created, and it's all the processing we need. Now with these two variables ready, starting from next lecture, we can finally start doing some vector math. Feel free to refer back to the video if you need help, and I'll see you in the next lecture.